Hello everyone, welcome to our channel Problematical. Let's start with the exercise 1.1 of sets from class 11th Maths NCERT. And the first question is, which of the following are sets? And justify your answer. First part is the collection of all the months of the year beginning with the letter J. Now we know that a set is a well-defined collection of objects. Well-defined means every element of a set should be different, should be unique, should have a specific meaning. Collection of all the months of the year beginning with letter J. Let's see if we can form the sets. If we are able to form sets, be it finite or infinite, we will call it sets. If they are not well defined, if there's any ambiguity with the meaning of ambiguity will be clear in the examples which are not sets, then we will not consider them as sets. Collection of all the months of the year, we know that all the months would be January, February, March, April, May, June, July, August, September, October, November, and December. So the year in the months beginning with J would be January, June, and July. These three values can clearly be written in the form of a set A. Hence, the answer of the first is, this is your set and it is a set. Because we can write it in the form of elements, hence it is a set. Second, the collection of 10 most talented writers of India. Now, if you say 10 most talented writers, here you have ambiguity, here you have confusion. 10 talented writers according to whom? According to the writers themselves, according to the people who read them, read their work, you, me, whom. So the second one is not a set. A team of 11 best cricket batsmen of the year. Again, most talented, best cricket batsman. Here, which batsman is at the top? And based on what? Which factors? Whether based on the most runs scored or the most time on the field. We cannot say which factor are we considering, and it's not specified that which as a factor is being considered while considering a person to be the best cricket batsman. So this is also not a set. Wherever we cannot split the given information into well-defined elements, we will call them not a set. Collection of all boys in your class. Now, if you see a collection of all boys in your class, there would be a specific number and you can mention all their names or all their roll numbers in a form of set. Say B1 is the first boy, B2 is the second, B3 is the third, and so on. All the boys over here in your class till Bn can be mentioned in the form of set, each element representing one boy. So this can be represented in the form of elements, hence it is a set. A collection of all natural numbers less than 100. First of all, natural numbers less than 100 means from 1, natural numbers start till 1 and till 99. Because you're not considering 100, you will end up till 99. These are also well defined. We will not have any more than 99 elements over here, and this will have a fixed number and every element is well defined. Hence, this is a set. A collection of novels written by the writer Munshi Premchand. So, Munshi Premchand would have written a specific number of novels. I do not remember how many, but he would have written a specific number of novels. So, these number of novels would be a natural number. They are counting numbers. You cannot have 1.5 books. So there's no ambiguity. There's a fixed number. And all these book names can be represented in a form of set. So the first book name, second book name, third book name, fourth book name, they can be mentioned here till your final number, say n. That's why it is a set. A collection of all 11 all even integers. Now, when you say all even integers, you mean integers which can be either negative, which are negative or positive, but which are even in number, multiples of 2. So set of all x such that x is equals to 2n, where n belongs to z. This is your set 7, set of all even numbers. So it is a set. It would be an infinite set because there would be infinite positive values and infinite negative values, which will be even in nature. The collection of questions in this chapter. Now, if you count all the questions in this chapter, it will have a specific number. You can mention all these questions in a set. Question 1, question 2, question 3. So all these sets can be mentioned over here as elements of a set. Let's call the set as A. Since you can represent this in the form of elements and it has a specific meaning, every element has a specific meaning, hence it is a set. A collection of most dangerous animals of the world. Now, most, again, something like most dangerous, least dangerous, best or worst. These words are indications that this is perspective based. This is according to some criteria. And if that particular criteria, according to specific situations are mentioned and the elements can be derived from it, then it's fine. But here, nothing else is mentioned. Most word is used. According to whom is not specified, hence it's not a set. So in this question, there are 3 values, second, third, and sixth, and ninth, which are not sets. The rest all are sets. Next question. Let A be a given set of 6 elements 1 to 6. Insert the appropriate symbol belongs to or does not belong to in the blank spaces. The dotted part is the blank spaces. So first part, 5-A. Whether 5 belongs to A. Is 5 an element of A? Yes, we can find 5 over here. So it belongs to 8-A. Can you find 8 over here in the elements of A? No, so it does not belong to A. 0-A. 0 does not belong to A, so 0 does not belong to A. All you have to do is check whether the left-hand value of your dash or dotted line is present as an element of A or not. 4 belongs to A because 4 is an element of A. 2, we have 2. 2 belongs to A. 10, there is no 10, so 10 does not belong to A. When you use belongs to or does not belong to, the left-hand side value is an element and the right-hand side value is a set name or a set. Next. Write the following sets in roster form. Now, roster form is when you're mentioning all the elements of a set. The given sets are in set builder forms where you use words to describe a common relation amongst the elements of a set. First set A given is a set of all x such that x is an integer and -3 less than equals to x less than 7. So x is an integer. We know there are specific integers, and here you have on the number line, let's imagine a number line first. You have a number line, you have a specific value 3 on it, -3 on it, which is your leftmost value. -3, -2, -1, these are elements. 0, these are integers. 1, you'll move on till 7. 2, 3, 4, 5, 6, and 7. X less than equals to -3. So -3 is included. All these values are included. Okay? And x less than 7 means 7 is not included. So from here till here, how many elements do you have? A will be equals to, counting from left hand side, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. If you have any problem with this symbol, what is this? Or if you have any doubt with theory of sets, you can watch another video on sets in the playlist. So B is equals to x, all x, such that x is a natural number less than 6. Now let's redraw the number line. If you can do it without a number line, well, then it's good. If you cannot imagine as of now, it's fine. You just draw the number line and then place the condition there. X is a natural number. We know that natural numbers start from 1. We'll only mention those numbers which are part of the given conditions. So X is a natural number. X is a natural number. So natural numbers start with 1 and it is less than 6. 2, 3, 4, 5. That's it. We cannot write 6 because you need values less than 6. Now less than does not mean including 6. If it would have been written less than equals to 6, then 6 would have been considered. So here B set will be equals to 1, 2, 3, 4, and 5. Next, C is a set of all x such that x is a 2-digit natural number such that the sum of its digits is 8. So a 2-digit natural number whose number of digits is 8. We know that in natural number it starts with 1. The smallest 2-digit number would be is 10. Beyond 10, if you add the digits, is 1. 1 plus 1 is 2. So we need such a digit which starts with 1 but whose addition is 8. So it is 17. 17 value will give you digit 8. Next, increment this 1 and decrement the 7. So 2 plus 6 is 8. 3 plus 5 is 8. 4 plus 4 is 8. 5 plus 3. 6 plus 2. 7 plus 1 and 8 plus 0. So we need 2-digit natural numbers whose sum is 8. So all these values are elements of such a set. So your C value becomes equals to 17, 26, 35. I'm erasing these. 44, 53, 62, 71, and 80. Next, D is a set of all x such as x is a prime number which is divisor of 60. Divisor of 60 means a factor of 60. So it has to be a prime number and it has to be a factor of 60. What does this mean? You have to factorize 60 first. The factors of 60 would be 1, it is divisible by 2, 3, 4, 5. Let's say 1 into 60 is 60. 2 into 30. 3 into 20. 4 into 15. 5 into 12. 5. Then you have 6 into 10. What else? Do you have any other factors? 7, 8, 9, 10, 11, and no, because 6 till 10, and then you can repeat these values. But we know that all these values are composite numbers. Which are prime numbers amongst these? You have 2, 3, and 5. We do not have any other prime numbers. So the D set is equals to set of 2, 3, and 5. E, a set of all letters in the word trigonometry. Now we know that elements of the set should not be repeated, or even if they are repeated, they hold the same meaning. So it's irrelevant or redundant to write them over and over again. So let's start with the first alphabet, T. Just mention any alphabet which is unique as an element. R, I, G, O, N. Again, the second O is the first repetition, so we need not write it because we've already written it. Then you have M, E. T is the second repetition, R is the third repetition, and then you have Y. So these are the elements of the set. All you have to do is write the letters of this word. F is a set of all the letters in the word better. Here T is a repetition, repeated, and E is repeated. So we write them only once. B, E, T, and R. Next. Fourth question. Write the following sets in the set builder form. You have to write the sets in the set builder form. Means that you have to find a relation amongst these sets. The first, 3, 6, 9, 12. So let us call this set as set A. Try to find the relation. There are 4 elements over here. This is 3, this is 6, 9, 12. This all 4 belong to the table of 3. 3 can be written as 3 into 1. 6 is 3 into 2. 9, 3 into 3. And 12, 3 into 4. Observe a linear incrementation 1, 2, 3, 4. You know that 1, 2, 3, 4 are natural numbers. Natural numbers less than 5 or natural numbers less than equals to 4. And all values are multiplied by 3, a common factor. So I can write this as a set of all x such that x is equals to 3n. These are n values. N is equals to 1, 2, 3, 4. Where n belongs to a natural number, n is a natural number, and it is not an infinite natural number, it is less than 5. Instead of less than 5, you can also write n is less than equals to 4 or 1 less than equals to n less than equals to 4. So the same value can be written in set builder form in 2 methods. Try to use as many symbols as possible and as less words as possible. In the previous question, we saw that you had x is a natural number. It is more wordy. Your set builder form is a lot of words are included, where you could have easily written this as B is a set of all x such that x belongs to natural number and x is less than 6. So this is expected. A more concise, a more reduced form is much more expected than a wordy statement or a wordy set builder form. Second question. Let B is equals to 2, 4, 8, 16, 32. Again, you can write these as 2 into 1, 2 into 2, 2 into 4, 2 into 8, 2 into 16. As you can see, this is 2 raised to power 1. This is 2 square. This is 2 cube, 2 raised to power 4, and 2 raised to power 5. If you take 2 common, observe the pattern is shifted. This 2, this is 4, this is 8, this is 16. If you find a shift in the pattern, then definitely it is squares. If you cannot observe the squares, this is another hint for it. Obviously, you should be able to observe squares. B is equals to this one. So square. Your powers are moving linearly. You're incrementing linearly from 1, 2, 3, 4, 5. So now n has 5 values, 1, 2, 3, 4, 5. And n is a natural number. And n is less than 16, less than 6. So here it can be written as B is a set of all x such that x is equals to, this is 2 base is common, your power is equals to n, and your n is varying from 1 to 5. such that n belongs to a natural number, no value is less than 1, and n is less than 6. We will keep it as simple and as short as possible. 5, 25, 125, 625. The pattern here can be 5 to the power 1, 5 to the power 2, 5 to the power 3, and 5 to the power 4. So your base is common, base is 5, which is fixed. Your powers are shifting from 1 to 4. So it can easily be written as a set of all x such that x is equals to 5 to the power n belongs to a natural number, and n is less than 5. Fourth, 2, 4, 6, and dot dot so on. But this is simple. It's a set of even natural numbers. So you can write this in set builder form as x is a set of all x such that x is here in the, if you want to write in the form of statement, you can write this as x is an even natural number. In the form of symbols, it is x is equals to 2n, n belongs to capital N, and n is, that's it, enough. It's a natural number and its value is 2n. So if you place n is equals to 1, you'll get x is equals to 2, n is equals to 2, you'll get x is equals to 4, n is equals to 3, you get x is equals to 6, and so on. Next. Your next values are 1, 4, 9 till 100. Now these are 1 square, 2 square, 3 square till 10 square, 100. One, 4, 9 till 100, which can be written as 1 square, 2 square, 3 square, 4 square, and 5 square. Six square, 7 square, 8 square, 9 square, 10 square. That's it. These are all your values because last value is 100. So here you have a common pattern. Something to the power 2. The base value is n to the power 2, and n can hold any value from 1 to 10. So this is a set of all x such that x is equals to n square. N is a natural number and the value of n lies between 1 till 10. Or you can write n less than 11. Next. List all the elements of the following sets. Now listing the elements is equivalent to mentioning the elements, which is your roster form. So your first set is x is an odd natural number. Now, odd natural number means your natural numbers, odd natural numbers start from 1, 1, 3, 5, 7, 9. Since there are infinite, we'll just write dot 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 and be done. Second, b is an integer and minus 1 by 2 less than x less than minus 9 by 2. So let's draw a number line, represent these points on the number line. We need integers. One second. Right. This is minus 1 by 2. let's write it in the form of decimals first, so it's a good idea. -1 by 2 less than x less than minus 9 plus 9 by 2. It's not minus 9 by 2, it's plus 9 by 2. One second, let me correct this. Yeah. So minus 1 by 2 is the left hand side value and plus 9 by 2 is the right hand side value. 9 by 2 is a positive number on the right hand side of origin or O, and minus 1 by 2 on the left hand side of 0. Minus 1 by 2, 0.5 lies between 0 and 1. This is minus 1. Then you have 9 by 2. 9 by 2 is 4.5. So it will lie between 4 and 5. 1, 2, 3, 4. And between 4 and 5, you have 9 by 2. Always convert it into decimals for better clarity. So these two are the values that we are supposed to consider. And you have to find out all the integers. X is an integer between these values, not including these values by default. So x would be an integer from this value to this value. Let's write it out. 0, 1, 2, 3, and 4. C is equals to x is an integer such that x square is less than equals to 4. Now x square is less than equals to 4. Again, let's draw the number line. Ideally, it can be solved with calculation. Your equation is x square is less than equals to 4. And x is an integer. So let's consider which values will be less than equals to 4. If you place 0 on the number line, 0 square is 0, which is less than 4. So the condition is true. For all the values on the number line, which are integers and for which this condition is true, such values will be there in your roster form. Such values will be the elements of the set. Next, you have 1 on the left hand side and minus 1 on the -1 on the left hand side, 1 on the right. If you place -1 over here, -1 square is 1 square, which is also less than 4, and 1 square is 1 square, which is also less than 4. -2. -2 square is 4. 4 less than equals to 4, which means 4 is equals to 4. 4 less than equals to 4. Here, the condition is true, because either the value should on the left hand side should be less than or it should be equals to 4. 4 is equals to 4, condition becomes true. On the right hand side, the same will be true for 2 as well. So the elements of C will become -2, -1, 0, 1, and 2. Next. D is X such that X is a letter in the word loyal. All you have to do is list all the letters in the word loyal. L, O, Y, A, and L we won't write it because L is already written. One element is written once. Fifth. E is X such that X is a month not having 31 days. So E, January 31 days, February, March 31 days, April, May 31, June, July 31, August 31, September 30, October 31, November 30, December 31. X is a set of all X such that X, F is a set of all X such that X is a consonant in the English alphabet which precedes K. Precedes K is which is before K. A, B, C, D, E, F, G, H, I, J, K. Before K, that means K is not considered. You're supposed to consider consonants, so these are vowels A and E and I. So remaining alphabets will be considered as part of your set. F is equals to B, C, D, F, G, H, and G. Next. Match each of the set on the left of the left in the rooster form with the same set on the right described in set builder form. On the left you have the rooster form, on the right you have set builder form. So let's convert these sets into rooster forms first. So A is a prime number and a divisor of 6. We know that 6 can be split into 1 into 6, 2 into 3. And it has to be prime number, so it cannot be 1 or 6. It has to be 2 or 3. So A is 2, 3. B, an odd natural number less than 10. It is an odd or natural number. Natural means definitely not less than 1. Odd number starting from 1, less than 10, 1, 3, 5, 7, 9. We cannot include 11 because 11 is greater than 10. X is a natural number and a divisor of 6. Now, there is no restriction whether it's a prime number or not, so we can include all the divisors or all the factors. X is a letter in the word mathematics. So, D is equals to M, A, T, H, E. M is repeated, A is repeated, T is repeated, I, C, S. Now we'll match. Your A is equivalent to 2, 3, which is second. A is equals to second. Your B is equals to 13579, 13579. This is your B. Next, your C is equals to 1236. This is your C. And your D is equals to just 1. So that ends your this exercise. We'll continue in the next class. Thank you.